Welcome everyone. Today I'm starting physics, and in physics, I'm not starting with the very first topic like forces, acceleration. Instead, I'm thinking to start with the waves because waves is a very vast a portion in GCSEs. It has the electromagnetic waves as well, light waves, sound waves, and there are a lot of questions they can ask, and there are high chances that the student can get confused. So this is the reason I thought to start with the waves first in this GCSE crash course. So let me start with the basic definition of waves. But before that, I'm running GCSE batches. It's a crash course batch, and we don't have much time. Like, I understand you all be stressing out at this point of time. So if you need a very quick revision, a very quick help, you can enroll yourself for it. Or if you're looking for just the doubt session, that means specifically you are looking for some particular doubts, then you can just email us at exactacademy@gmail.com your queries, how you want the classes to be, and even for the demo, and we'll coordinate accordingly. So let me start with a chapter, that is waves. With the basic definition of waves, waves are any disturbance in a given medium. Any disturbance, that means suppose there is, let me take an example of speaker. Obviously, if you're not turning it on, there is equal balance in the energy, but as soon as you turn on the speaker, definitely, say for example this is the speaker, and when you turn it on, definitely the particles around the speaker will start to vibrate, and when they gain the vibration, that means they have the energy now. What will happen that the molecules or the particles near to the speaker will have a higher energy, whereas suppose you are standing here somewhere, so the particles around you have the lower energy, and we all know that energy always travels from higher level to lower level, so the energy starts to flow, and that energy when travels, it travels in a form of wave. So wave is a medium to transfer energy from one point to another point. So when wave travels, only the energy that is being transferred, no matter mass being transferred, that's important thing. Whenever there is objective or fill in the blanks, they give you this type of question, that wave transfer dash and doesn't transfer dash, that means wave transfer energy, purely energy, but it doesn't transfer mass and matter. That's important. Discuss about the types of waves, but before I discuss the type of waves, there is a small thing that I have to describe, is that there are further the two types of categorization of the waves, that is called a mechanical wave and electromagnetic wave. A whole electromagnetic wave is there in the syllabus, and the mechanical waves are basically those kind of waves that needs a medium to travel. The mechanical, definitely you might have not heard this word because that's not completely used in the textbooks, but it's very important to describe this one, that the mechanical waves are the kind of waves that needs the medium to travel. Like if I say the seismic waves or the sound waves, they need the medium to travel, whereas the electromagnetic waves, these are the seven different waves, they need no medium to travel, and they are developed by a different waves. That means electromagnetic waves, the waves that are produced by oscillating electrical and magnetic fields, and definitely this will be discussing later. As of now, there is an important categorization which is there commonly in our curriculum, and that is the longitudinal waves and the transverse waves. Why it was important for me to describe the mechanical waves? Because they need a medium to travel, and when these waves travel, then the particles vibrate, and in order according to how the particles are vibrating, they are categorized as the transverse waves and the longitudinal waves. So let me describe with the longitudinal waves first. As I told you that these are those waves in which the particles vibrate, the particles of the given medium, it can be, or in which whatever be the medium, or the oscillation of the photons, whatever it is, the particles are vibrating. That's the most important thing, and how they are vibrating, that categorized in them as the longitudinal and transverse waves. In longitudinal waves, the particles vibrate in to and fro motion, Now you might be thinking, what is to and fro motion? To and fro motion is a motion of the pendulum. How pendulum rotate moves. If you see pendulum move like this, then come back this, then go back, go this, then come back this. So this is how they move, and this kind of motion is called to and fro motion. What happens is, while vibrating the particles, the wave transfer, the energy transfer in forward direction, because we just described what are waves. Waves are the way of transferring the energy from one medium to another medium, basically. So from one part to another part, this is the first part, this is the second part, and the energy is being transferred. So it's transferring in this direction, and simultaneously what's happening, particles are also moving, because it's the particles that are transferring energy. So what happens, like these are the particles, and this particle gained the energy. Now this particle will transfer energy to this particle, then this particle, then this particle. So in this way the energy is transferring in forward direction. And how energy is transferring, energy is being transferred by the particles itself. So particles transfer by the vibration, because particle gains that energy, so they start to vibrate. And what kind of motion they exhibit while they vibrate? When they are vibrating, they can move up and down, to and fro. So in longitudinal waves, they move to and fro. So these particles move to and fro, then to and fro, and in this way they keep on transferring energy in forward direction. Now if I talk about their direction, I can say that the direction of the vibration of particle is like this. They are moving forward, backward, and the wave is transferring forward direction as well. So you can clearly see that they both are parallel to each other, and that this whole description makes the proper definition of a longitudinal wave, which is, we can say that in longitudinal waves, how the particles are vibrating, they are moving to and fro, and thus by moving like that they are transferring energy. But the exam definition that you are supposed to write is that in longitudinal waves are those kinds of waves in which the direction of motion of the particle, because we have seen they are moving to and fro, and the wave motion, that is the transfer of energy, the direction of transfer of energy, they both are parallel. So in longitudinal waves, the direction of motion of particles is parallel to the wave motion. And some of the examples of the uh, longitudinal waves are seismic P waves, sound waves, ultrasound waves, etc. 2 or 3 if you learn, that will be more than enough. But at least you should be aware. They can ask you that, okay, tell us that these waves are dash type of waves, longitudinal, transverse, on an objective also they can ask you. So at least you should be aware of it. But on hand, like on tips, you should be learning these three, because in while answering you are supposed to, if it's a 2 marker, you have given the definition, but it will be a great add-on if you give example of the type of waves 1 or 2 would work. Now let me see how exactly the longitudinal waves transfer the energy. So what happens in a longitudinal waves? The particles, as I described, you move to and fro. So suppose these particles, obviously all particles, especially if I talk about the particle of the gas, they are not arranged in a pattern. They are just randomly arranged. So like one particle is here, one is here, one is here, something like that. And this particle gained the energy, so it moves to and fro. So the particle that will come in its path will gain the energy, and then it starts to move like to and fro. Then here particle will gain the energy, and it's like to and fro. So when it's like backward motion, so it's not necessary that all are moving in forward and all are moving in backward. Maybe some are moving in forward, some are moving in backward. That means suppose these particles, they are moving in forward. These particles are moving backward. This is the way by they are moving. This is a to and fro motion, but they all are moving in a different direction. So what happens in a longitudinal wave, that all the particles come closer to each other and creates a zone of high pressure zone, because when all particles come closer while moving, they just come closer to each other. This is the first phase, because they are now compressing each other. The particles are compressing each other, and compressing each other, that means it creates a high pressure zone. And this high pressure zone is called compression. Like the process of compressing each other, this is a compression. So you can say compressing each other and compression. Now after they do it, they transfer energy to each other, and then now they move away from each other in order to transfer energy to the other particles. Then they move away from each other like this. Now what's happening? Particles are now away from each other. Particles are away from each other. And if they are away from each other, that means it's a low pressure zone, because they are not pressurizing each other, they are not exerting any pressure on each other. So it's ultimately a low pressure zone, and this low pressure zone is called rarefaction. Like the process is basically your rarefaction. So again, all the particles will come closer to each other. So what's happening? The particles come closer to each other, then they move away from each other, then come closer to each other, then they move away from each other. And in this way, they are transferring energy, like by compression, rarefaction, compression, rarefaction. It's just like kind of, you can take an analogy of a caterpillar. So what a caterpillar does, it squeezes its body and then releases its body, then it squeezes its body, then it releases its body, and in order of like in doing so, it keeps on moving in forward direction. And same thing is happening here. Or you can take an analogy of a spring. When you're compressing spring, then it's expanding, then compressing, then it's extending, and like if you release it, it can jump, it can move. So that kind of motion is happening. So how longitudinal wave travel? A longitudinal wave travels by compression and rarefaction. So I'm writing a particular answer right here. So if like in exam they're asking you what how the longitudinal waves travel, so that would be your answer. You have to write that longitudinal waves travel by compression and rarefaction, whereas compression is what it refers to when the particles are closer to each other, they're compressing each other and creating a high pressure zone, whereas the rarefaction refers to when the particles are spread out and it creates a low pressure zone. The next one is transverse wave. A transverse wave, in this, the particles vibrate up and down. Just like we have seen that in longitudinal waves, they move like to and fro. Similarly, in transverse wave, the particles move up and down. So like they move up, then down, then up, then down. And in this way, they keep on transferring energy from one particle to another particle. When they transfer to the next, then this also start to move up and down. You can think it an analogy to the rabbits. They actually hop, they move up and down, they jump, and while doing that, they keep on moving in forward direction. And same thing happens here, that while moving up and down, these particles keeps on transferring energy in forward direction. So where the energy is transferring? In a forward direction. That's happening. Forward, and it's up and down. So the direction of motion of the particles is like this, and they make a perpendicular. And from here you can write the definition. So from this, what we can conclude about the transverse waves? So this is the basic definition that we discussed, that in transverse waves the particles vibrate up and down, and while doing that and while vibrating, they keep on transferring energy. Exam definition that you have to write, you need not to write these all things there in the exam. The exam definition would be precisely this, that in this wave the direction of vibration of particle is perpendicular to the wave motion. Example of such waves are, you can say, seismic S waves. We will definitely be discussing about what are seismic waves, what are P and S waves, how they travel, how they propagate. The second would be the light waves, or we can say all electromagnetic waves, etc. These are some of the examples of transverse wave. Now let me see some of the definitions that is related to the waves. Let me plot it, the graph on displacement time axis. That means we can say that y represents the displacement, whereas x represents the time. This is a wave pattern, and that is drawn in displacement time graph. Now there are some things that some parameters that we have to describe. We know that the loci, if we plot all the locus on a graph and join them together, we'll get a curve. That means suppose my equation is y is equals to 2x plus 3. So I will find all those coordinates that will satisfy this equation. That means when I put x is equals to 1, y will be 5. So 1 comma 5 will be the first point that will satisfy this equation. Similarly, on putting 2, I'll get y as 7. So 2 comma 7 will be the next point that will satisfy this equation. So one by one, I'll plot all the coordinates that will satisfy this equation and join them together. In this case, this will be a straight line. Similarly, this graph will be for when I plot all the locus, or simple if I plot all the displacements. If even take an example of transverse wave. In transverse wave, particle vibrate up and down. There should be a certain maximum displacement or maximum height up to which it can jump. It can't jump above it. When the particle is here, while jumping, if the particle is here, I'm plotting that displacement here at this time. Say for example, particle starts to jump at t is equals to 0. T is equals to 0, that means it has just started. Then after few microseconds, that particle is here. That means the time would be something and displacement is here. So you'll get a coordinate like this. Then again, after few seconds or after few microseconds or nanoseconds, the particle will be here. This is now the displacement here, here, here. Now it will reach maximum at t something, whatever be the time. We will get this point. So when I plot all the displacement comparing to their time, that means at what time the particle is showing what displacement from the mean position. That means when mean position is when the particles are resting, they are not vibrating at all. From that position, whatever be the displacement, that when you plot it on a graph and join them together, you will get this curve. That means this point will represent the maximum displacement. This is the maximum displacement or maximum height up to which a particle can jump or particle can move away from the mean position. And this maximum displacement is called amplitude. So this is called amplitude. The distance between these two consecutive peaks, this is known as wavelength, or you can say length of one complete wave. The wave has started moving from this point till this point. So this length that it has covered while completing one wave, one complete cycle, because after this it keeps on repeating itself. You can see again it's showing the same whole curve. So like sine wave is, it's like this, then again start to move like this. So like it's a periodic when it keeps on showing the same behavior. So the length covered by, or the distance covered by a wave in its one complete cycle is the wavelength, or the definition that we use mostly for our exam is the distance between two consecutive peaks or two consecutive troughs. That will give you the wavelength. The next is frequency, but before that let me write down the definition of amplitude and wavelength. So this is the basic definition that we discussed, that amplitude is the maximum displacement of a particle from the mean position, and wavelength is the distance traveled by the wave when it completes its one cycle. But mostly if you are writing the GCSEs, the better option is to write this definition: distance between two consecutive peaks and troughs. Okay, now the third one is, this is my first definition, the second one. The third one is called frequency. Even from the word you can understand that frequency is, generally we say how frequent something happens. Frequent, that means when something keeps on repeating itself. So here also the frequency is the number of vibrations in a second. That means we just discussed that how waves travel. Wave travels by vibration of particles. Particle vibrate, transfer energy, and thus wave travels. So how many times each particle is vibrating in a second gives the frequency. Or you can say the number of wave completion, that means this whole one wave, that how many number of cycles have been completed in 1 second is the frequency. Okay, and also
the unit of wavelength, the standard unit I'm talking about of wavelength is definitely, wavelength is a length and length is in meters. So I'm talking about the standard unit should be in meters. And same I can said it would be a meter, the standard unit I'm talking about. Now the next is definition of frequency. So here definition is the number of vibrations of a particles in second or number of waves completed in a second is called frequency, and the unit of frequency is hertz. So suppose it says describe what is 220 hertz. It means the particles are vibrating 220 times in a second. That is the number of vibrations in a second. That is the frequency. So 220 hertz means they are vibrating 220 times in a second. The next definition is time period. The time period is the time taken by one particle to complete its one cycle. Okay, by a wave to complete its one cycle, by the particle to complete its one vibration, that is the time period. So we can say the time period is time taken by a wave to complete its one cycle. One cycle, that means how much time it took to move from here to here. This is the one complete cycle. That will give you the time period. And definitely if it's a time, so the unit is in seconds. There is a relationship between the time period and the frequency, which is time period is equals to 1 over frequency, which is one of the most important formula you will find questions on in GCSE final papers. So this was the very basic introduction of waves, and I'm just completing this right now. In the next section, that means in our part 2, I'll be discussing the sound waves and ultrasound waves. Its application will deep like dive into that in the next class. And so far, it's only I'm ending it here. Even the speed of time frequency, that is the formula to calculate the speed of the wave, which includes the frequency and wavelength, that all we'll be discussing in the next class along with the sound waves. So that's it for today. Okay, like I say in every video that I'm running GCSE batches. So if you want to book a demo, you can email us at exactacademy@gmail.com. We are running the uh, doubt sessions as well. If you have a particular doubt and you want to enroll only one or two classes just to clear your doubts, you can do that as well. If you are looking to enroll for a whole new class, new batches from year 1 to year 13 for all subjects, just email us at exactacademy@gmail.com and we'll coordinate accordingly. I have tutors for all subjects and they are highly experienced and educated. So that's it for today. Thank you. Have a great day.